All right, welcome to Unit 1, Lesson 2, Part 2. We're picking up where Part 1 video left off. So, let's get started. Applications of what we've been learning, okay? You have a coupon good for $5 off the price of any large pizza. You also get a 10% discount if you show your student ID. If a pizza is regularly priced at $15, is it better to apply the coupon or the discount first? Justify your answer. First off, what I tell everybody, this word justify, that just means show all your work, okay? You do not have to write a paragraph. If they say explain, you need to write words. We're going to write some words at the end because we're obviously got to make a decision of which is better to apply the coupon or discount first. So we need to state that at the end. All right. But justify or justification can be math work shown on how we've gotten the answer. So we need to do two things. Okay. We need to do two things here. And that's the first thing that should pop in your mind when you read this problem. Okay, they're asking me, should I apply the coupon first or the discount first? So I'm going to have to figure out the cost of that pizza, applying the coupon first. And then I'm going to have to figure out the cost of the pizza, applying the discount first. So I've got to do two setups, okay? So it doesn't tell you that you need to set up equations, but I'm going to set up equations anyways, just so you can see this, all right? So first, let's do the coupon first. Coupon first, then the discount, all right? So if P is the price of the pizza, $15, okay? And I'm gonna apply my coupon first. The coupon is good for $5 off. So my coupon is gonna be the price minus $5, all right? After I calculate that, we're going to apply the discount. Now, my discount tells me, all right, I take whatever value I have and I take 10% off. So right now, I'm going to take the price of pizza with the coupon taken off first. So I'm going to take the price of the pizza after I apply the coupon. I'm going to subtract 10% of what the coupon price is, meaning 10% times whatever the coupon is, okay? Because I want to figure out, well, what's 10% of the price I got to pay now, and subtract that from the price. That's what the discount is. So let's do this, all right? I'm going to take $15 for P. That's 15 minus 5. That gives me $10, okay? So my cost of the pizza with just the coupon would be $10. Now that $10 is C, all right? So my discount is going to be $10 minus 0.10, is 10% of $10, okay? I need to subtract 10% of $10 from $10. So if I do this math, that ends up being 1. 10 minus 1, that means I would pay $9 for my pizza. If I apply the coupon first, then the discount second. All right? That's one thing I need to do. The second thing I need to do is I need to apply the discount first, then the coupon. And some of my math students will be like, isn't that the same thing? No, it is not. That's why this is relevant, especially for pizza, because everybody loves pizza. All right, so I'm going to apply my discount first. I'm going to take my price of the pizza, and I'm going to subtract 10% of it, 10% times price. After I get that amount, I'm going to apply my coupon, which means I'm going to take whatever the discounted price is and subtract $5 because I have a $5 off coupon. Okay, same deal. So let's do this. I'm going to put a 15 in for P. All right, so my discount is 15 minus 0.10 times 15, okay? This right here would be $1.50. So I'm going to take $15 and subtract $1.50, all right? I'm going to end up with $13.50. That is just the discount. I still need to apply the coupon to that price. So now, if this is my P value, my discounted price, that goes right here. So my coupon is my discounted price minus the $5 coupon. And that would give me $8.50. Okay? Now, you did the math for both scenarios. The coupon first, then the discount, that's on the left. Or the discount first, then the coupon, that's on the right. Obviously, this one right here is cheaper by 50 cents. They want to know, okay, is it better to apply the coupon or the discount first? Well, you need to state that, okay? Justification for your statement is this math. But you need to state it's better to apply discounts first. Okay, this is your answer right here. This is your justification, okay? Both of those math, that math work is your justification for your answer. So make sure you actually answer the question, all right? Number 2. All right, let's move this up here, make a little bit more room. Put this right here. Put this right here. Good to go. Physics students are studying the effects of temperature, which we will call T, on the speed of sound, which we call S. All right? They find that the speed of sound in meters per second is a function of temperature in degrees Kelvin. Okay. So in order to find speed, I can find speed if I know Kelvin. This right here is telling me I can find speed if I have Kelvin. Okay, and I use the square root of 410 times whatever temperature Kelvin I have. Okay? The degrees Kelvin is a function of temperature in Celsius. Okay, and they give us this equation telling us, well, we can find Kelvin if we know Celsius. All right? And if you remember anything from science, you figure out Kelvin by taking Celsius and adding 273.15 to it. Okay? So let's find the speed of sound when the temperature is 30 degrees Celsius. All right, they give us this, 30 degrees Celsius. I cannot use this yet because I need Kelvin. I have Celsius. But I can find Kelvin because I have Celsius, using this right here. So I need, ultimately, to find out what my Kelvin is, okay? This is what I ultimately need to use. I need this. I don't have that, okay? But this is what I have. Celsius is 30 degrees, right? I can find Kelvin using Celsius. So I'm going to take Kelvin of 30. That means I put a 30 in for my Celsius. Okay? Forgot the 0.15. Very important. In math, you can't miss any numbers. So if I add this, I get 303.15. That's actually what Kelvin would be when Celsius is 30 degrees. Okay? So now I have Kelvin. Now if I have Kelvin, now I can find my speed because I have Kelvin now. All right? So let's do this. I'm going to figure out my speed is when I have 303.15 for my degrees Kelvin. So that's the square root of 410 times 303.15. I do not expect you to know how to do that. And there it is, I already had it done. I do not expect you to know how to do that off the top of your head. There it is. So, all right, when I do this calculation, I get 352 points. Well, here we go, 549. They want this to the nearest 10. The nearest 10 would be this number right here is a 5. Okay? Will that 5 go up to 6 or stay at 5? It will stay at 5 because the number after it is a 4. And what's my label? The speed is in meters per second. Meters per second. There you go. All right, on to the next one. Average rate of change. The average rate of change for a function y equals f of x over the interval from a to b is f of b minus f of a all over b minus a. This may look slightly different from the way we're used to seeing it. We're used to seeing it y2 minus y1 over x2 minus x1. And you should know that that is really slope, isn't it? This thing right here is how we calculate slope when we're given 2 points. All right? So, anytime you see rate of change, you should automatically be thinking slope. Now, what about this thing right here? Okay, they're just telling you if you're given an interval, like if I'm given from 1 to 5, okay, these are x values. From when x is 1 to x is 5. Sorry, like that. So if this was A and this was B, okay, and I'm using this equation right here, I would have 5 minus 1 on the bottom, all right? And what would I have on the top? Well, how do I find my y value when my x is 5? Well, I put it into the function. That would give me the y value. Same thing with my 1. So really, this is y when x is 5. So that really is a y value, isn't it? It's the y value that goes with this x. This is y when x is 1. That's really the y value to this x. So really, it's the same thing here. This y value goes with this x value, and this y value goes with this x value. They're all related. It's just different notation. It's just using the notation that we're using now with that function notation. All right? So don't be scared. We're going to do some problems. All right. First things first. Let's draw the graph. F of x equals x minus 2 squared plus 3. All right? And I know that's a parabola. You can put this in your calculator with your table of points. But I know that's going to go up 3 and to the right 2. So here's going to be my vertex. It's going to go up 1 on each side. And then when x is 1, 2, 3, 4, that's going to be 2 squared equals 7. 4, 5, 6, 7. I believe that would be right here. This right here will be the graph. Done. All right. Next, it wants us to plot the points 0, 7, and 3, 4. 0, 7 happens to be right here on that point. Okay. And 3, 4 happens to be right here on this point. All right. We drew these. Now they want us to draw a line segment connecting them. So I'm going to, line segment would look like this. of this line segment we just drew. All right, so I'm going to say y2 minus y1 over x2 minus x1. So I'm going to call this my x1 and my y1, x2 and y2, right? We've got 4 minus 7 over 3 minus 0. That's negative 3 over 3. My slope of the line segment is negative 1. All right? That seems simple. If I went a little fast, you could rewind it and watch it again. But I don't think that's too crazy. Now they want us, using the average rate of change formula from above, from the previous slide, find the average rate of change of our f of x function. That's what we drew in blue here. Okay, they want us to find the average rate of change of this bad boy. Okay, that's our parabola. Okay. From when x is 0 to x is 3. Yeah, I crossed those right out. Go under it a little bit because it's off the smartboard. They want it from this point, when x is 0, and to when x is 3, that's this point. So over this interval, they want the slope. Well, let's do that. Okay, so they want the interval from when x is 0 to x is 3. This is my A and my B. They want us to use f of B minus f of A all over B minus A. All right? So let's plug these in. B is 3. So f of 3, yeah, it's bad, minus f of A, 0, all over B minus A. All right? Well, what's my function again? My function is x minus 2 squared plus 3. So before we do any work, let's just verify. Yeah? X minus 2 squared plus 3. All right? So what we're going to do is let's figure out what f of 3 is. F of 3 is, okay, 3 minus 2 squared plus 3. Well, 3 minus 2 is 1. 1 squared is 1. Plus 3, that would be 4. All right? So this right here is the same thing as saying 4. Okay, at the bottom we have 3 minus 0 still. Let's figure out what f of 0 is. F of 0 is 0 minus 2 squared plus 3. All right, well, that's negative 2. If I square negative 2, I get 4. 4 plus 3 is 7. Okay, so f of 0 is 7. And look what we have here. Look at this point and what we did here. It's the same thing because when x is 3, my y is 4. When x is 3, my y is 4. When x is 0, my y was 7. When x is 0, my y was 7. That should be the same because we are taking the same points, right? This point and this point. That line went through those 2 points that we're taking the slope of. And our rate of change is between those 2 points. And they're shared. They're the same points. And rate of change is slope. This ends up being negative 1, just like it was right here. Okay? You can see how they're the same. Okay, example 2. They actually give us a table of points here, okay? X's go from negative 2, negative 1, 0, 1, and 2. My Y's go negative 8, negative 1, 0, 1, and 8. Determine the average rate of change of Y over the interval from when X is negative 1 to when X is positive 1. X is negative 1 here. X is positive 1 here. All right? So, they want us from negative 1 to positive 1. This is my A, and that's my B. I'm going to set up f of B minus f of A all over B minus A. Now, if you get this, you don't have to rewrite that equation every time. I'm just doing it for your sake here. Okay, so the bottom is B minus A. Don't forget you're subtracting a negative. All right? Now, what is f of B? That's the y value for this x value. So when x is 1, what's my y? 1. All right? And again, when my x is A, what's my y value for that? So when x is negative 1, what's my y value? Minus a negative 1. Well, that's 1 plus 1. That's 2 over 2. That's a slope of 1 right there. The average rate of change is 1. Now, they want us to do the same thing for part B, but this time they give us from negative 2, yeah, that's my B value, to 1. So now I'm going from, let me clear this out, from negative 2 to 1, that interval. Now, I'm not going to rewrite this every single time, okay? If changing x or changing y, it's slow, and I have 2 points, don't I? So I'm going to take y2 minus y1, so it's negative 8 minus a negative 1, minus 1. Minus 1 on the top, those are my y values, over my x values, negative 2 minus 1. The top is negative 9 over a negative 3, and if I divide those, there you go. Plain and simple. Example 3 is a typical Regents problem. It says determine which of the following functions has the greater average rate of change over the interval from 2 to 5 and explain your reason. All right. Well, I need to find the slope from 2 to 5. Because remember, the rate of change, that just means slope, right? From 2 to 5 of g of x and of f of x. And obviously, we need to figure out which one is greater. So which one is going to be a bigger number, okay? Let's take a look at these things right now. From 2 to 5. So if I know my x values go from 2 to 5, I need to find the y values when x is 2 and when x is 5. So I do that by simply plugging in my x's. That's 8 plus 3, that's 11. So one coordinate is 2, 11. My next coordinate is 5, isn't it? Our next x value is 5, so I find f of 5. That's 4 times 5 plus 3. That's 20 and 3. So the coordinate here is 5, 23. Now I have 2 coordinates, all right? x1, y1, x2, y2. I'm going to say 23 minus 11 over 5 minus 2. The top will be 12 over 3. And if I divide that out, it comes out evenly, 4. My slope for the function f of x from the interval 2 to 5 is 4. All right? Now, it's a lot easier when they give you the table because you don't have to do this in the table and this because they give us the y values. From 2 to 5, those are our coordinates right there. I'm going to say this is y1, this is x1, this is x2, this is y2. Look at that. We don't have to do any of this calculation because they gave it to us in the table. Let's go. 26 minus 11 over 5 minus 2. That is 15 over 3. And if I do that division right, that's 5. Can I answer the question? No, I've got 2 numbers. I haven't stated which one is greater. And now I need to explain. Remember earlier in the notes, if you remember earlier in the notes, justification was math work. Explaining means using words. So we need to pick one of these and explain why we think it's greater. Okay, so I'm going to say g of x as greater, and I'm going to use their words. Greater, and what do they use in the problem? Average rate of change? What's average rate of change? Yes, they did. As a greater average rate of change, period. Now I got to explain why. I got to explain. Because, and I guess that should be a capital B, because its slope is larger. If it has a larger slope, it has a greater average rate of change, because rate of change is slope. And if the slope is larger, the average rate of change is also larger. All right? This is stuff that we've done in Algebra 1, probably in 8th grade math. Okay? Maybe even 7th, I'm not even sure, but definitely 8th. Guaranteed in 9th.